Hi everyone, this video is an exercise 11 in question 4, part B. So we have 1 over 1 plus root x minus 1, and we want to integrate this. So first of all, remember that this fraction cannot be integrated by the methods that we have used before, such as reverse chain rule or standard results. So this is u substitution. And we normally take what we have under the square root as equal to u, but in this case we can actually take root x minus 1 equal to u, because on the denominator we have two terms, and if we leave the square root and just take what is inside of that as equal to u, then still that doesn't reduce the complexity of the fraction. But when we take the entire of the square root equal to u, then that allows us to have some nice algebra. So we take u equal to root x minus 1, and which is equal to u u to the u is equal to x minus 1 to the power of half, and now we differentiate that and we get a half times x minus 1 to the power minus a half. But this can be rewritten as a half times 1 over root x minus 1. And here notice that root x minus 1 is essentially what we said that is equal to u. So here we can simply substitute u into root x minus 1, because that's our substitution to begin with. So then this becomes du by dx is equal to 1 over 2u. And at this point we just rearrange this to make dx a subject, and dx is equal to 2u times du. And now we just need to transform the limits. So when x is equal to 5, then we substitute that into a formula. So again, u is equal to root x minus 1. So when x is equal to 5, we'll have root 5 minus 1, which is equal to 2. And then when x is equal to the lower limit, which is 2, then we get root 2 minus 1, which is just 1. So now we have everything to substitute into the integral. So the integral is now is here. So is the integral is 1 over 1 plus u, because root x minus 1 is equal to u. And now we substitute what we got here. Dx is equal to 2u times du into dx. So we get this integral. Now we can simplify, or actually just multiply, and we get 2u over 1 plus u du. Now here is a very interesting algebraic trick that we can use, because if we rewrite this as 2 times u over 1 plus u, still, as you can see, there is a problem, because we can't really integrate this by reverse chain rule, for example, or just using the natural log, because natural log of 1 plus u, when you differentiate that, you won't get u over 1 plus u, you won't have u on the numerator, so that doesn't work. But we can use an algebraic trick, which is basically saying that, so consider u over 1 plus u here, so u over 1 plus u. Now you can rewrite the numerator as u plus 1 minus 1, right? Because 1 minus 1 is 0, so it doesn't make a difference. But this helps us to allows us to split the fraction, so we can have two terms basically. So u plus 1 over 1 plus u, and then minus 1 over u plus 1. And interestingly, u plus 1 over 1 plus u is just 1, and then we get 1 minus 1 plus u. So now the difference is that we can easily integrate this expression, right? So that's why inside of the bracket we can now have 1 minus 1 over 1 plus u, and now we can expand the bracket, so we get 2 times minus 2 over 1 plus u, and finally 2 simply integrates to 2u, and then 2 over 1 minus 2 over 1 plus u is ln, because ln of 1 plus u differentiates to 1 over 1 plus u, and then we have this minus 2 to account for here. And now we just substitute the limits, and we get 2 plus 2 ln 2 over 3.